Okay, the first piece of code that I would like to go through is how to make an inverted filter. And this is done by first running a for loop that runs up to the total amount of pixels I have. This will make sure that I check every single pixel that I have in my input image. And the for loop is only something I will run through when I describe this exact function, because it is something that I will keep using through, yes, actually every single function that I make a filter in. So what I do in this exact function is that my output, which will be the inverted image, is equal to 255 minus the output, which will take a color and invert it to the opposite. This means, like, if I have a red color in my output, it will turn green. And this is the result of taking the pixel value that I have in the input image and then separating it from 255 pixels. And if I run it, let me just show you how it is showed. Yes. Okay, pay close attention to this picture over here. There you go. Compared to my original image, you can see as my skin is of course not red, but it's going this direction, so it is turned green afterwards. Yes, that's it. This is filter number 2, which is simply a simple brightness filter, and this filter allows me to increase or decrease the brightness of my output, and this is done by checking each single pixel we have for my input, and then I've created this variable which is far up in my code, where I can increase or decrease the value. This is simply because I'm adding a parameter or decreasing a parameter. Actually, I've done this way that I have a if statement longer down here, as you can see. So if I hit the E button, it will allow me to increase or decrease, and if I hit the D button. And this is also something I use in some of the other filters. So this will be the only time that I show you this. Okay, going back. Well, okay, right now I just can't find my code, so I'm just gonna show you the principle of this exact filter. I'm gonna draw it for you. Like, we have an output, and the output is going to be input, and input plus brightness, and B that we have here is my variable called brightness inside my code. And what I do here is that I already have the for loop that checks each individual pixel that I have in my input, and by then plussing it with brightness, I change the pixel value, and I can increase the value and I can decrease the value. And just to show you how this exactly works, I'm just gonna run the code for you. pay attention to the video clip on the right. Alright, now I am increasing the brightness like this, and now I'm decreasing again. And this is simply by pressing the keys, the key listener that I created with my if statement. Yes. In the book, on page 46, we have the equation for changing the contrast of a picture. And here, if we want an output, which we have here, with a changed contrast, we will need a changing factor, which is here, which is what changes the contrast, and we will have to multiply it with the input. And this is done in my code right here. I'm creating a variable that consists, or not consists, but is supposed to be the changed value of the input and turn it into the changed contrast. And the contrast variable that I have here is once again a variable that I have far up in my code with an initial value, and this if statement that I have here, that I also have in my brightness filter, is something I make in order to keep inside the values 255 and 0, so that I don't have pixel values higher than that, because these are the only pixel values that I am able to use. I only have pixel values between 0 and 255 in this particular case. And I will just demonstrate quickly that my code actually works. Once again, pay attention to the video on the right. Increasing contrast, boom, and getting back to normal, and decreasing the contrast. And of course it turns 0 because now I have a minus value. So yeah. Next filter is the log image filter, and this is first done by creating a variable that creates something called scaling constant, and this ensures that the maximum output value is 255, and this is entirely based on the equation we have inside the book, as well as what my input is supposed to be, where I take the scaling constant and multiply it with the logarithm of 1 plus my input right here. And the same thing is done in the exponential filter, and here I just have a different kind of scaling constant. This is and it has actually the exact same purpose, which that this scaling constant makes sure that the output value is 255. This is just something that has to be done differently because we're dealing with exponential equation. 255 divided by the power of 1.004, and why I exactly have 1.004, this is actually something that is supposed to be a parameter that can be used to change a shape of the transformation curve. And no, this is not it. This is the maximum pixel value in the input image, and k is this number, and it is normally chosen as a number just above 1, and this is just above 1, as you can see, and this will enhance details in the bright areas and while decreasing detail in the dark areas. And actually I think this is pretty much enough what I have to say about these two filters, because they're entirely based on what is in the book, but I'm just showing you that I did actually know what I was doing. More or less I was following, or actually turning the equations I had inside the book into code. Yeah, I'm just quickly demonstrating for you that I was actually able to make my logarithmic and exponential filter working. And once again, look on the picture on the right. This is my logarithmic filter, and this is my exponential filter. There you go. Okay, the next filter is a gamma filter, and in order to understand this I would just like you to show a short demonstration of the equation that I've taken from the books, page 47 in Introduction to Video and Image Processing. And first, what I wish to do is that I have my pixel value, which is demonstrated here, which is V1 right here, and I wish to work inside the interval. I wish to transform into the interval 0 and 1, and this is done by dividing with 2.55, and so then we have the transformation inside the interval 0 and 1. Then the gamma mapping is performed by taking my transformation to the power of my gamma value, right, which is y and v2. And then lastly I wish to map it back to interval 0 and 255, and this is done by multiplying it with 255. Yes, and just to show you how this is done in my code, I have a for loop here that checks the height and the width of my input. Then here I check for all the red pixels, the green pixels, and the blue pixels. Then I change to the interval 0 and 1, dividing with 255 for each pixel value, or each color value, as you can see. And last but not least, I have here the gamma mapping in itself for each of the three colors, and mapping it back to interval to the last interval that I have just here. And these if statements I have down here is once again to make sure that I keep inside my my pixel values 0 to 255 and don't have any pixel values above or beneath this. And I'm just gonna demonstrate that it actually works for you once again. I'm gonna demonstrate that it works. Once again, the right. And this is with a gamma value of 1, 2, free. Yeah, that's it. To create salt and pepper noise, we once again have our for loops and third for loop that checks for colors and says that the output is equal to the input, all with color. Then I create an integer called number and checks the remainder, and this will check the remainder of 100. If I take something and divide it by 100, what do I have left? And this is something that will be keep updating the whole time, change the whole time while my update function is running. And if this number is less than 12, this will create a new variable that will take the remainder of 2. And if this remainder is equal to 0, then take a pixel value and turn it into black or else turn it into white. So it will keep taking different and random variables, or not variables, pixels from my input and turning the color to either black or white. Once again demonstrating that it works. Boom. Here you see it, or here you have it. That's my salt and pepper noise. In alpha blending, we once again in the book Introduction to Video and Image Processing on page 65 we have the equation saying the alpha blending output is equal to my alpha blending value times input of my first picture plus 1 minus my alpha value and multiplying it with my input of my second image. And inside my code I've done it with a grayscale and with inverted image, if I'm not mistaken. I can't quite remember. And I have this equation in my code right here, and the alpha value is once again a variable that I'm able to change with my keyboard, and I'm making sure that I keep inside a certain limit. So we have the maximum pixel value of one image and of another. And once again I'm gonna show you that it works. Inside my code, and here I change that value. Boom, turned into inverted. It works by increasing the alpha value. Yeah. Next filter is to make RGB into a grayscale image, and this is done by first tracking for R, G and B pixel values, and then I create an on-site char variable called results, and here I completely eliminate the pixel, not the pixel value, but the color values of all the pixels, and only leaves them with intensity and contrast, and this will result in having output that is only in grayscales because we have eliminated the color values. And this is shown on the output I have in the middle of the screen, right next to my original image. Next filter is not something I wish to talk too much about because we haven't heard a lot of it, in image processing, not as far as I can remember, but it is definitely a filter that computes the inverse cosine of each pixel I have in my input, and gives me an output. And let me just demonstrate how it works, or that it actually works. I'm getting tired of this. Been doing this a lot this evening. Yeah, okay. Alright, here we go. This is it. This is how it looks like, if I'm not mistaken. Okay, quite remember. Let me just, well, yeah, that is actually one. Yeah, that's the one. Okay, so far I've been introducing the code to you in small bits where I've been cutting scenes, but now I'm just gonna try to describe the whole thing in one take, because I'm getting tired of preparing every single take, and it takes too long time. So I'm just gonna try and describe what I've been doing with the different filters the rest of the video, and not go too much into depth with things, but just demonstrate that I got things working. And the next filter I would like to tell you about is a filter that is able to increase and decrease the color depth. And first of all, I've created a value which is a parameter I can change with my keyboard. Once again, I check for all the colors, and I do this by creating new colors for my new input. This is for the red one, the green one, the blue one, so on. And I take my red value and process depth, the parameter I can change by increasing or decreasing it. Then I divide it with 2 and minus it with red again, plus depth divided by 2 and modulus depth minus 1. And it works. I got it in, let me just show you. Yeah. This one is case. Which case was it? This is the one. See what happens when I increase and decrease. Yep, that was this one. Moving on to the sepia filter. Where do I have it? Where do I have it? I have my sepia filter right here. Once again, check for the colors. I have a sum where I multiply with 2. Actually, I've seen this through another example through one of my friends, where you simply have to change the different. You have different sepia values for each color values, and these are actually someone I find. I think I bought these. No, it was in a book I found them. No, actually, it was on a website showing which kind of sepia values you had for each red, green, and blue. That's the reason why I multiply with them here, and I make, of course, again, if statement limit values to make sure that the output won't be too green. and also I divided here with 2 to make sure that I don't have values that are too high to fit inside. Let me just show you. Well, actually I'm not going to show you in the video, but you can take a look for yourself if you check my code, which of course you do. Okay, I'm going to show it to you anyways. Let me see. 14 and 14, yeah, orange color, it works. Alright, moving on to the next one, which is the pastel colors. I can just immediately show you the filter right here, next after my sepia. Also in the right output window. Okay, I'm going to show you the code. Pastel colors. Once again, I'm dealing with different pixel values. And then you simply just do this by increasing with 128. That's the how you get the pastel values. And once again dividing by 2, so I don't have values that are way too big to fit inside my output. Yeah, moving on to then pink color tracking. Yeah, and in this one I'm gonna use something different. I'm gonna use gray luminance, so just the texture which is called luminance instead of RGB. And this is the one, and I'm supposed to track for the color pink, so I'm just gonna show you. Here I have a pink marker. As you can see, it turns all the pink pixels white, tracking the pink color. Show you the code. Make color. Make. God damn it. Done. Make color D. I think I call it. Alright. Yes, I have. It's right here. Here it is. And what I'll do here is actually I use thresholding in an if statement, and I watch the pixel values, and actually the pink color consists of blue and red, so I was making a threshold that would look for blue pixels should be above green pixel plus 30, which 30 is my threshold value, and red pixels should also be higher than green plus 30. So this makes sure that I detect for the color pink, and then it should turn the output into white. So the pink pixels should be white, and the rest should be black. Yes, that was color detection. And now I'm gonna move on to mean filtering. And mean filtering was something also done in colors. Yeah, I got it right here. Make mean blur, like making blur with the mean filter. First of all, I have my kernel here on my filter. For loops, take my input pixels, and multiply it with the kernel. So making sure that the kernel or the filter runs through every single pixel. And this is also something I got managed to work. But, I'm going to show you. Reopen. Yeah, that's actually my the first one I did. As you can see, the new output is more blurred and also darker in the colors. Yeah, that one mean. A mean disk is it's actually pretty similar. I just took it was the same principle, just using 7 and 7 and then creating a disk. As you can see here, I have 0, 0, 0. It forms a disk as you have here. Okay, I just have to get some editing, get this shit done. Oh, what I haven't mentioned about my for loops is that I start with 2 and go up to km height -2, and this is because the mean filters have a problem with filtering the edge on the picture, so I'm skipping 2 pixels from the picture frame. Yeah, yeah, yeah. What about Gaussian though? What did I do there? Gaussian. Can't quite remember actually. Maybe am I misspelling it? Or what's going on? Yes, I am. I am misspelling it. Let's try again. What's going on? Gaussian blur, yeah. Here we have it. Actually, there was a example I followed on the internet. I mean, the Gaussian blur right here. Moving on to the next one. Okay, so Bell. What am I doing here? This is the problem with making things in a chronological order, that I can't find what I've been doing. This seems pretty unprofessional. It shouldn't happen again. Oh yeah, oh yeah. I know what happened. Okay, let's see here. Yeah. So Bell actually did that by very good. Yeah. Okay, here I had it. I used the same approach as using a mean filter. Then I found a vertical bell inside the book and a horizontal bell. I made 2 functions, one that looks for vertical and one that looks for horizontal, and then unite them in one single function. which I did with my cases up here. As you can see here, first I take my binary image, which is also a function I'm going to tell you about. I make the binary image, I put it into a function that looks for vertical sobel and one that looks for the horizontal. It then puts it out to the input, and this is case 10 in my GraphQL. Alright. Okay. 1, 2, 3, 4, 5, 6, 7. This is my vertical edge filter, and this is my sobel. Alright. Pre-width was a combination of using edge detection on vertical and on horizontal. So it was two separated functions using a vertical filter and a horizontal filter, but both with edge detection. Let me just show the code. Meta edge detection. Here, as you can see, I have the vertical, and here I have the horizontal, and I combine it in one. Once again, here I have it. Taking my binary image, taking this binary image and put it into edge detection with vertical and one with horizontal, and then I have the pre-width. Okay. Boom. Boom, 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 boom. Okay, I just want to tell you that I get the code for dilation, erosion, and opening. I'm going to show you how it works, because I've simply spent too much time trying to describe what actually happens here. But if you have any further questions, you are more than welcome to okay, I'm just gonna try and give a brief description. Maybe you won't understand it, but maybe you will. Make dilation. That's fine. Make dilation. It's one of the first cases I've actually been showing. Make dilation. Yeah. Make dilation. Alright. Here I have it. So what happens with dilation is that I've created a kernel, and it dilates when it goes over the input image, and if it fits, it will dilate. It won't dilate. Here we have it. Yeah, it does actually dilate the pixels. What we have here then is something called there was a closing where there's a dilation and an erosion, and then last but not least we also have an opening right here. But all these filters this is just a regular binary dilation. Yeah, actually put it in the correct order. I can't remember. Yeah, okay. Number 3 is a dilation. Number 4 is an erosion. Number 5 is closing, and number 6 is opening. Dilation, erosion, closing, and opening. Simply done by simply, well, I'm making things sound not simply right now, but this is because my head hurts and I'm tired. Yeah, we have relation here, and this dilates the binary input depending on if it fits or not. And then we have case 4. This deletes depending on if the binary image fits the kernel. And then we have a closing where we first want a dilation, then we want an erosion on the binary image. And then we have the opening. We first have our binary image, we want the erosion, and we run the dilation. And I'm sorry that I can't really go much into details with these things right now, but my head really hurts. But I hope that this whole thing is okay. But this was all for me, and I hope you enjoyed it. Bye.